Hello everyone, my name is Mamogo and you are welcome to Oxchem Academy. Now if you are new to my channel, kindly hit the subscription button below. Also like, share and of course avail yourself to the lessons so as not to be left behind. Welcome back. So in today's lesson, we're going to be continuing from our series under acid, base and salt. In our previous lessons, we have taught on acids, we have also talked about base, and we have also talked about salt. If you are yet to watch those videos, please kindly check them out in my channel. They are titled acid, base and salt, for acid, for base and for salt. Okay, but for today, in today's class, what we're going to be learning about is relative acidity and alkalinity. So let's get right into it. The first thing we're talking about is definition for a pH scale. Now, what is a pH scale? A pH scale is a scale of measurements used to determine the level of acidity and alkalinity of a substance. So in essence, a pH scale is used to measure the level of acidity or alkalinity of a particular substance. That is to say, how acidic a substance is or how alkaline a substance is. Now, the pH scale is measured from 0 to 14, and 7 being what? Neutral. So as you can see in the diagram in front of you, we have 0 and then we have 14. Now, 7 is neutral, and that is where water usually falls under. Now, anything from 6 to 1 is what? Your acidic, and anything from 8 to 14 is your alkaline or basic. Okay, now we have strongly acidic and weakly acidic. Decrease in pH value usually indicates increasing acidity. So the lower the numbers are, the more acidic the substance is, and then increase in alkalinity indicates that the substance is more basic. So for example, when the numbers are between 11, 12, 13, 14, that tells you that that substance is strongly alkaline. And then if it's between 8 to, let's say, 9, that is what? Weakly alkaline. It's the same thing for your acids. So from your 6, 5, that is weakly acidic. Then anything from your 0 to your 4 is what? Strongly acidic. Okay, so that is the role of a pH scale. Is basically to measure how acidic or alkaline a substance actually is. Okay, so that's it. What are the uses of your pH scale? Where can it be used? Okay, now some of the uses of the pH scale include agriculture. Certain plants cannot grow under certain soil conditions. So for example, like a tomato, that's an acidic fruit. Okay, so a tomato will not survive in a pH that is what? Basic. So you see that the pH of soil plays a very significant role in agriculture. Okay, certain plants cannot be grown in certain soils because of the pH level. So for example, in Benin, let's use Benin as a case study, we do not grow apples except maybe for the native kind. But the typical apples that you see is not grown in Benin. So you can find apples in places like Jos or in other foreign countries. Why? Because the pH of that soil is suitable enough to encourage the growth of that or to cultivate that particular plant. Okay, so another use of your pH aside from agriculture, it is useful in aquaculture, that is your marine life. Certain marine life animals cannot survive under certain pH level. So if the water is too acidic, it can be harmful to aquatic life, and if it is too basic, some marine lives or some fishes cannot survive in them. So pH is necessary, or pH determination is necessary in what? Aquaculture. Another importance is in pharmaceutical industry. That's the industries that produce drugs, and pH is also necessary in those industries. We also have food industries, and it's also useful in water treatment. So these are just a few of the uses of your pH scale. I hope you understand. So moving on, the next thing we'll be discussing are indicators. Okay, so under acid, base and salt, we have what we call indicators. So what are indicators? Indicators are known or are referred to as substances that change color when added to an acidic or basic medium. So an indicator is a substance which changes color when added to an acidic or basic medium. We have different types of indicators. We have your methyl orange, you have your methyl red, you also have phenolphthalein. There are more indicators. You also have your litmus paper. Okay, so these are examples of indicators. We have so many more, but these are the most popular type of indicators that we use in the laboratory. Okay, so like I said, indicators are substances that change color when placed in an acidic or basic medium. So they let you know whether the substance is acidic or whether it is what? Basic. In essence, they indicate, as the word indicator. So they indicate, they let you know. Okay, so that is what an indicator is. And I just gave you guys examples of what indicators. Okay, on your own you can do further research and get other types of indicators used in the laboratory. So that said, the next thing we're going to be discussing is color changes in acid and base medium. So we just talked about indicators. So what are those color changes that we can observe in an acidic or basic medium? So first things first, whenever you use methyl orange in an acid solution, the color change you will see is red. Okay, so when you use methyl orange in an acid solution, the color change indicated is red, and then in a basic medium it is what? Yellow. So same thing for your methyl orange, for your methyl red. I just talked about methyl orange. Same thing for your methyl red. In an acidic medium it is red, and in a basic medium it is what? Yellow. Then for your phenolphthalein, when you use phenolphthalein indicator in your acidic medium, it is colorless. Okay, so in your acidic medium it is colorless, while in your base phenolphthalein is red. So when you see these color changes, it will indicate to you whether your substance is an acid or a base. So like I said, the color change is dependent on the type of indicator used. I hope you understand. Okay, so for that said, lastly, we have what are buffer solutions. So what are buffer solutions? Buffer solutions are those substances that, or rather are those solutions that resist change in pH when an acid or a base is added to it. So a buffer solution resists change in pH when an acid or a base is added to it. Okay, so how is a buffer solution prepared? A buffer solution is prepared by reacting a weak acid with its conjugate base or a weak base with its conjugate acid. So you might now ask, what is the purpose of a buffer solution? A buffer solution tries to neutralize an acid or a base in order to make the pH stable. So that is the purpose of a buffer solution. A perfect example of buffer solution that is applicable to living organisms is blood. So the blood in our bodies serves as a buffer solution. Now you might ask, what are the uses of a buffer solution in our day-to-day lives? Buffer solutions are necessary in chemical reactions where stability of pH is mandatory or essential. Okay, so that is one use of a buffer solution. Another use is in the monitoring biological activities such as enzyme activities. So this is where pH finds its application, rather this is where buffer solution finds its application. So on your own, do further research, find out about more uses and examples of buffer solution. So this is what we'll be talking about today under relative acidity and alkalinity. Okay, so please, if you have any questions as pertains to this topic we just talked about, let me know in the comment section below. Also, if there's something I didn't mention but you want me to talk about, also let me know in the comment section below. If you have watched the video up to this point and you're here to subscribe, please kindly do that so as to be made aware when videos are uploaded to the platform. That said, I remain your tutor, Mamogo. Have a wonderful day.